Another episode of Power Logic. Now let's proceed to problem 3. Let triangle ABC be isosceles triangle with angle A is 90 degrees, which basically means that it's an isosceles right triangle. 45, 45, 90, be more precise. And there exists a point P inside ABC such that the angle PAB is equal to the angle PPC is equal to the angle PCA, and AP is equal to 10. Find the area of ABC. Okay. Now we always start with a diagram. Okay, and we know that these two are equal given by the problem statement. Now, PAB is equal to PB, the degree of angle PAB is equal to angle PBC is equal to angle PCA. So let's just say that there exists a point P. This might not be the best place. It should be somewhere here. Call it a P. And if we just draw a connection to all of the three vertices. Okay. Angle PAB is this angle. Angle PBC and angle PCA. These three angles are congruent. You might be asking, well, how these three angles are not even like connected, and we don't know whether these three triangles are like the same. And also the only thing we know is that AP is equal to 10. Or you might be thinking 3 angles. What about if they're in the same triangle? But triangle indeed does not work like that, and seems like we don't even know the angle of PBA from PBC, since we only know PBC, but PBA is 45 degree minus PBC, but we don't know PBC still. We only know that 3 angles are equal, and this length is equal to 10. So how are we going to possibly solve this problem? Now, okay, so let's just, without loss of generality, call this one to be alpha. We just chose a random character to represent it. Now this angle, which is angle PAB, is 90 minus alpha. And clearly we see that this is actually indeed a right angle. Well, because you know that in a triangle, when we look at this triangle, the three angle of a triangle must sum up to 180 degrees, and if you just do a simple addition, you can see that this angle APC is equal to 90 degrees. That is probably something that is really powerful. Now, if we look at this angle, oopsies, this angle is 45 degree minus alpha, because we know that angle C is indeed a 45 degree angle. And now, if we look at this angle, the angle of BPC, that angle is equal to 135 plus alpha. No, that angle is indeed equal to 135. There's no alpha. And because we know that these three angles must sum up to 360, because we're doing one rotation in radian form through surrounding this point, so this angle must indeed be 135 also. Okay. And we also know that this is 45 minus alpha. Okay. Now if we just look at this triangle and this triangle, do you see any similarities? Well, definitely, right? This angle marked here, marked blue, is actually the same as this angle, which more precisely, the angle PBA is equal to the angle PCB, and the angle PBC is congruent to the angle BAP. And since these are both 135 degrees, then they're indeed congruent. Now, we can just do some kind of triangle similarity equation, and we can actually use this condition that this is equal to 10. Okay. Now what? How do you proceed? Now if we look at the opposite of this angle, then you can see that that this length actually corresponds exactly to the length of triangle PBC. And AF and FE can also be used. So essentially we're gonna have this equation that that AP over PB is actually equal to PB over PC. And this simplifies to PB squared is equal to PA times PC. But now, do we know what PB is and what is PA? Well, PA is equal to 10, so essentially PB squared is equal to 10 times PC. But we're going to find the area, so essentially if we can find PC, then we can just use Pythagorean theorem to find the length of AC, and AC squared over 2 is just the area of this triangle. Okay, now we got to this part. What else can we do? Well, we don't know PB and we don't know PC, so it seems like we're actually being stuck right here because we don't know. We have two variables, but we need one of the variable. So now, we know that these two triangles are similar, so essentially the last pair of sides, which is the ratio, the exact ratio is that the ratio of PA to PC. So this is actually equal to AB over BC. And what is AB over BC? Well, we know that this triangle is 1, 2, 1, 2, square root of 2, so essentially this one is equal to 1 over square root of 2. Okay, so now can we find the expression of PC? Or can we find the value of PB? Because AP over PB is equal to 1 over square root of 2. So this just gives us PB is equal to 10 root 2 square, which is equal to 200. So this seems like PC now becomes really trivial. PC is just equal to 20. Okay, so PC is equal to 20, and now problem becomes really easy because AC is equal to the square root of 10 squared plus 20 squared, which is equal to square root of 500, and 500 is equal to 5 times 100, but we know that this value is equal to 10 squared. So essentially the square root of 500 is equal to 10 times the square root of 5. So we know that one of the side length is 10 root 5, so the area just equal to 1/2 times BH equal to 1/2 times 10 root 5, but we know that both of the bases are 10 root 5, so we take the square, we're gonna get 500 over 2, which is equal to 250, and that is indeed our answer to this problem. 50. Now let's go on to the next problem. Let x, y, and z be real numbers satisfying the system of equations. xy plus 4z is equal to 60, yz plus 4x is equal to 60, and zx plus 4y is equal to 60. Let S be the set of all possible values of x. Find the sum of the squares of the elements of S. Okay, so we have three variables, x, y, and z, and we have to know all the variables. And there are three equations, but none of them are linear. So if you try to solve this with linearly, then it's probably not going to be a good idea. So let's just first see that, well, we have both y here, and we have an x and a z, and we also have an x and z. So let's just say that this one's m1, this equation's m2, and this equation's m3. So first, let's just try by subtracting m1 minus m2. Now we can see that, well, because 60 minus 60 is equal to 0, and the other side, the left-hand side, becomes because x minus z times y plus 4 times z minus x, that is equal to 60, and then we can just factor this a little bit. Then we get x minus z times 4 plus y. No, times y minus 4. Sorry, y minus 4. That is equal to 0. Okay, so we're gonna have two cases. The first case is if x is equal to z. So if x is equal to z, then we can just look at the first equation and the third equation, because if x is equal to z, then then m1 and m2 are essentially the same. So if x is equal to z, why not we just replace every appearance of x to be z? Then we're gonna have this system, which is first xy plus 4x is equal to 60, and we also have the second equation, which is x squared plus 4y equal to 60. Okay, but this still seems to be not that clear of what to do. Now actually we can just first factor the first equation to be x times y plus 4 is equal to 60, and x squared plus 4y is also equal to 60. So now why don't we just now why don't we just substitute y into x? Well, why should I substitute x? So we're gonna have x squared plus 60 over 60 over x minus 4, and then multiply this by 4, and that gives 60. So x squared plus 240 over x minus 16 is equal to 60. So x squared plus 240 over x is equal to 76. Okay, so now we can clearly see that there's a solution of x is equal to 4. But since we want to find all the solutions, then we want to first factor this. We have x cubed plus 240, no, minus 76x plus 240, and that is equal to 0. So we see that since 4 is a solution, then we can just do some long division. X minus 4, x cubed, 0x squared minus 76x plus 240, and x squared, x cubed, 4x squared, and 4x squared minus 76x. And that would be plus 4x. Then essentially we have 4x squared minus 16x minus 60x plus 240, and that would give us minus 60. Okay, so this one can indeed be factored in, into x minus 2 times x squared plus 4x minus 60. And now, in order to solve this equation, then we can simply just do some complete the square. Well, we have x minus 2 squared is equal to 64. So x minus 2 is plus 0 equal to 8, plus 0 minus 8. So essentially we have x can be equal to negative 6, or x is equal to 10. So in this case, we have these two equations, but we're going to find all the possible values of x. So for the first case, we're going to have, well, x is equal to 6, negative 6, negative 10, and don't remember in the beginning we got one of the equation, or one of the solution, which is 4. Wait, sorry, this one should be 4, not 2. So we have these three. Now let's just look at the second case. When y is equal to 4. So now, when y is equal to 4, then we can just still use m1 and m3. So m1 will just be 4 times, we will have this system, which is 4 times x plus z is equal to 60. And also we have zx plus 4y is equal to 60, but y is equal to 4. So zx plus 4 squared is equal to 60. So this gives xz is equal to 44. Okay, so we have this system, which is x plus z is equal to 15 and xz equal to 44. So from here, we can just use some Vieta's formula to get that this is actually the solution to the quadratic of x squared minus 15x plus 44 equals to 0. Now I can just do some quadratic formula to get that is equal to negative b plus or minus the square root of b squared minus 4 ac over 2a, which is equal to 15 plus or minus the square root of 225 minus 176 over 2, and this, but then we know that this one is equal to 49, which is equal to 7, the square root of 49, which is equal to 7, so this one just becomes 15 plus or minus 7 over 2. Since I should be more precise here, since this x is not the same as this x. The x here is just a simple variable. So this basically just gives us 11 and 11 and 4. But we know that 4 already exists, so we have to add only 11 to our list. And, well, because we have done all the cases, so these are indeed the only 4 values of this equation of the values of x. So now, since we want to find the sum of the squares, then we're going to have negative 6 squared plus negative 10. Oh, sorry, it should be positive 10. And then plus 4 squared plus 11 squared. And that seems to be pretty straightforward, so try not make any mistake in the computation. I'm gonna get 52 plus 121 plus 100 is equal to 173 plus 100, and giving us 273. And that is indeed our answer to this problem. Thank you for watching, hope you enjoyed, and I will see you in the next video. Goodbye.